mutual recursion occurs when two different functions call each other. So now we're finally going to implement the Lund algorithm, which is actually used to compute the checksum of a credit card number. So here's the description from Wikipedia. From the rightmost digit, which is the check digit, moving left, double the value of every second digit. If product of this doubling operation is greater than 9, then sum the digits of the products. Take the sum of all the digits. So how does this work? Well, let's compute the Lund sum of 138743. We do that by taking each digit, except for every other digit, which I've grayed out, gets doubled. Starting from the rightmost, 3 just becomes 3, 4 gets doubled to 8, 7 is 7, 8 gets doubled to 16. Since the result of the operation is greater than 9, we then sum 1 and 6 to get 7. 3 is 3 and 1 is 2. So then 2 plus 3 plus 7 plus 7 plus 8 plus 3 is 30. And a valid credit card number will always have a Lund sum, which is a multiple of 10. So what's the point? Well, the nice thing about the Lund sum is that if any one digit is incorrect, then the Lund sum will be something other than a multiple of 10. Moreover, almost all transpositions, so say I switch the 4 and the 7, will be detected by the Lund sum algorithm and give a result that's not a multiple of 10. So let's write a function that computes this. The Lund sum of n. Well, it's very similar to sum digits. If n is less than 10, then we just return n. Otherwise, we get the last digit, and we're going to return something plus the last digit. But that something will be not a call to Lund sum, but instead a call to Lund sum double. And what the double version will do is it will double the last digit and sum its digits if necessary before adding that digit in, as we specified before. Okay, so a Lund sum just takes the last digit if there's only one, otherwise it does this doubling. So let's compute that double digit. So the first thing we'll do is we'll break up n, and then we'll compute the Lund digit, which is the sum of the digits of 2 times the last. Now, if n is less than 10, we just return the Lund digit. Otherwise, we'll return the Lund sum of all but the last digit plus the Lund digit that we computed, that one that got doubled. So notice that Lund sum calls Lund sum double, and Lund sum double calls Lund sum. This is mutual recursion, when two functions call each other. Now base cases can appear in both those functions or in only one. In this case, we see that it appears in both. Okay, so the Lund sum of just the number 2 is 2. But if I look at 32, then the 3 gets doubled to 6, and plus 2 is 8. And if I take the Lund sum of a valid credit card number, so here's a valid MasterCard number. It doesn't work, but it's within the range of numbers that MasterCard uses. Then we'll get a Lund sum, which is a multiple of 10, such as 20. So if you want to try this out on your own credit card, you can check to make sure that it's valid by making sure that its Lund sum is a multiple of 10. Or if that's too much work, you can just send your credit card number to me. I'll check it for you.